In this video, let's see an FFT algorithm. Okay, so there are two types of FFT algorithm. Okay, one is DIT, decimation time, other one is decimation frequency. So here the question is, compute the FFT using DIT algorithm for the sequence x of n equal to 1, 2, 3, 4, 4, 3, 2, 1. Okay, so given the sequence, you are asked to find the Fourier transform of the sequence using DIT FFT. Okay, so for using DIT FFT algorithm, the basic understanding that you should have is so we will be using butterfly diagram to solve this. For example, okay, so if you are very clear with this understanding, it will be very easy. Okay, so for an DIT FFT, DIT FFT, and so that is 2 method. Okay, if this is your input and this is your weight W and K. Okay, so the output at this point is going to be A. Okay, here the weight is going to be 1 and here the weight is going to be -1. So the output at this point is nothing but A into 1, which is A, plus B into W and K. Okay, B into W and K. Okay, so this A into 1 plus B into W and K. Okay, yeah, this, and the output B at this point is going to be this A. Okay, this A. Then here we have B into W and K into -1. So it is minus B into W and K. So if you're clear with this understanding, it will be very easy to solve the problem. Okay, so other thing that you should know is, please know the length of the sequence. In the given question, the length of the sequence is 8. So which can be which we can write as 2 power 3, and it denotes it as 3 stages. Okay, if the length of sequence is 4, which is 2 power 2, and we can say it as 2 stages. Given the sequence, x of n, and we could find the length of sequence is 8. From this you can understand the is going to have 3 stages. Okay, so let me show you the structure of the butterfly diagram before we go start. So this is the structure of your FFT algorithm. Okay, it has 3 stages: stage 1, 2, and 3. Okay, and what you can understand is the input here is bit reversed. Okay, x of 0, then you have x of 1, x of 2, x of 3, x of 4, x of 5, 6, and so the input is bit reversed. Then you have stage 1. Okay, the output of stage 1 acts as the input for stage 2. Okay, the weight here is going to be W20 for each one of this, and W20 is nothing but it has value of 1. So how we have calculated is W is nothing but a total factor which has the value e power j2 pi. Okay, so so W, the general is W and K, and so here the value of K is 0 and here the value of n is 2. Okay, so if you're going to substitute the value of 0 and 2, is e power 0 is going to be 1. Okay, so similarly you can just substitute the value of this total factor and you'll get W20, W40 is 1, and W41 is going to be minus j. Okay, and so coming to this point, as I have told you, in DIT the input is bit reversed. So in the first stage, what you can see is, we have to compute 4. Okay, this is 1 2-point DFT, this is 1 2-point DFT, or 4 2-point DFTs, and the second stage, we combine 2 2-point DFT to get a 4-point DFT. Again, the weight is going to be here W40 and W41, which is 1 and minus j. Okay, and then stage we actually combine 4-point DFTs to get an 8-point DFT. Okay, so this is an 8-point DFT. So here again, what you should know is the weight here is W80, 81, 82, and 83. So this is a basic structure which you should remember. Okay, so for any DIT FFT algorithm, please remember the structure, and you should also know how to compute it. Okay, so if you know this, it's very easy to solve the problem. Yeah, right. So this is how we compute it. You have seen. Okay, so I've told you how to compute. This is a plus b into w and k, and this is nothing but a minus b into w and k. So let's go to the problem now. And one more thing, if you want to know how the input is bit reversed, you are getting here x of 0, x of 4, x of 2, x of 6. Very easy to remember it. Okay, write 0 to 7 binary form. You get 0, 0, 0 for 0, and for 1 you can write 0, 0, 1. 2 will write as 0, 1, 0. 3 write as 0, 1, 1. 4 you may write as 1, 0, 0. 5 will write as 1, 0, 1. 6 will write as 1, 1, 0, and 7 write as 1, 1, 1. Okay, so if you just bit reverse it, write the reverse order. Okay, and you will get 0, 0, 0. This is no problem. Write it in this order. Okay, and this is going to be 1 is going to be 1, 0, 0, and again 2 is going to be nothing but 0, 1, 0. That's no change. 3 is going to be 1, 1, 0, 1, 1, 0, and 4 is going to be 0, 0, 1. 5 is going to be 1, 0, 1. 6 is going to be 0, 1, 1. And 7 is going to be 1, 1, 1. So this is 0, and this is 4. This is your 2. This is going to be 6, right? Yeah, 6. This is going to be 1. This is going to be like 5. This is going to be 6, and this is going to be 7, right? This is going to be 7. And if you see the 0, 4, 2, 6, this is what you can see here. X of 0, x of 0, x of 2, x of 4, 6, and 1, 5, 3, 7. 1, 5, 3. This is how the input is bit reversed. Okay, so without wasting much time, let's go into the problem. So what I'm doing here is I'm drawing the structure. It's very easy. In second stage, line 1 and 3 will form the pair. Okay, just connect 1 and 3 and connect 2 and 4. Here the weight is going to be 1, here is going to be minus 1, here is going to be 1 and minus 1. And here we have line 5 and 7 is going to form a pair. Okay, line 5 and 7. So 1, minus 1, and 6 and 8, again 1, here it's going to be minus 1. And here the weight is going to be 1, it's going to be minus j, 1 minus j. Okay, here it's all going to be 1, 1, 1, 1. Okay, so in stage 3 you should not this is line 1 and 5. Okay, is going to form a pair. So like just connect 1 and 5. Okay, again this is going to have the weight of 1, minus 1 is going to be 1, W80. So sorry, stops here. 2 and 6 is going to form a pair. This is 1, this is minus 1. Here is going to be 1 by 2, W81. So it's 1 by 2 minus j into 1 by root 2. Okay, and here this 3 is going to form a pair. Again, weight is 1, here is going to be minus 1. The weight here is W82, so it's like minus j. And again, the last 2. Okay, this is 1, this is minus 1. Here the weight is going to be W83, so it's like minus 1 by root 2 minus j 1 by root 2. So here what you're going to get is the output. Okay, so yeah, so first if an DIT question is asked, okay, if an DIT FFT is asked, just draw the structure. Okay, the next thing that you should know is you are supposed to, mark the input. Okay, please remember the basic mistake everyone does is the input is bit reversed. Please follow this. Okay, so don't write the input in sequence. This is x of 0. X of 0 value is 1. Okay, again we have x of 0 is 1. X of 1 is going to be 2. X of 3 is going to come here. Is going to be value of 3. And x of 4 is going to be 4 here. And here is going to be x of 5. It's going to have the value of 4. And x of 6 is going to have value of 3. X of 7 is going to have value of 2. X of the last value is going to be here 1. Okay, so x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6 and x of 7. Okay, please mark this correctly. Okay, the input is bit reverse. So just remember how we got this. Okay, so you have seen previously. Okay, so now it's very basic. Okay, so here just remember this, right? Keep this in mind. Remember this structure. Okay, that's it. Okay, here is going to be 1 into 1 plus 4 into 1. So it's 1 plus 4. Here the output is going to be 5. Okay, so here is going to be 1. Okay, 1, and 4 into 1 is 1. Again 4 into minus 1 is going to be minus 4. So it's 1 minus 4. Here is going to be minus 3, right? 1 minus 4 is going to be minus 3 here. Again, what's going to be here? 3 plus 2. Here is going to be 5. 3 plus 2. Okay, here is going to be 3 minus, 2 into 1 is 1. 1 into minus 1 is 1. So it is 3 minus 2 is going to be 1 at this point. Okay, here is going to be 2 plus 3, 5. And again here it is 3 into 1 into minus 1. So it's 2 minus 3. It's going to be minus 1 at this point. So 4 plus 1. 4 plus 1 is going to be 5 here. Again 4. 1 into 1 is 1. Again 1 into minus 1 is minus 1. So 4 minus 1 is going to be 3 at this point. So that's it. So what you should know is the output of stage 1, it's going to be the input of stage 2. Okay, that's it. Yeah, we'll just go find the output of stage 2 now. Okay, the same method and same algorithm. The only thing is in stage 2 maybe the line 1 and 3 has formed the pair and 2 and 4 has formed the pair. Okay, so this point is going to be 5 into 1. Okay, it's going to be 5 plus, okay, here's 1. So again here it's 5. So 5 into 1. Okay, so 5 plus 5. This point is going to be 10 at this point. Okay, so what's at this point? If we see this point, here we have minus 3. So minus 3. Okay, minus 3 we have. Then here minus j. Here you have minus j. Alright. So here you have 1. So 1 into minus j is minus j. So it's going to be minus 3 minus j. And what about this? Okay, this is going to be, and what about this? This is going to be like 5. We have 5 here. Okay, 5. And 5 into 1. Okay, so into minus 5. So 5 minus 5 is going to be 0. This 5. Okay, plus 5 into 1 is 1, and 1 into minus 1 is, 5 into 1 is 5, and 5 into minus 1 is minus 5. So 5 minus 5 is going to be 0. So this point we're going to have minus 3 is already there. So minus 3. Okay, and here 1. So 1 into minus j is minus j, and minus j into minus 1 is plus j. So minus 3 plus j. Okay, so what about this point? So we have 5. 5 into 1 is 5, and 5 into 1 is 5. So here is going to be 10 again. So what about here? here you have minus 1, so minus 1, then we have 3 into minus j, so minus 1 minus 3j, this point. So what about here? So here is going to have 5, okay, 5, then we have 5 into 1 is 5, and 5 into minus 1 is minus 5. So 5 minus 5 is going to be 0 here. And what about this? And if you say like minus 1, then we have 3 into minus j is, 3 into minus j is minus 3j, into minus 1 is plus 3j. So it is minus 1, okay, plus 3j. So we have find the output of stage 2. Now this output will be the input for the third stage, okay. Let's compute the third stage. So it is 10, okay, for third stage. Here the line and 1 and 5 is going to form a pair, 2 and 6, 3 and 7, 4 and 8, okay. So 1 and 5, so it is, here we are input as 10, and here is going to be 10, so 10 plus 10, here output is 20, okay. So here it's going to be, here it is minus 3 minus j, okay, into 1, so it is minus 3 minus j plus, okay, this come here we having minus 1 minus 3j, so into this weight, so plus minus 1 minus 3j, so minus 1 minus 3, let me take it, minus 1 minus 3j into 1 by 2 minus j into 1 by root 2, okay. This is plus term, and this is the product of this, both product of this into this, okay, this plus this into this. What about this term? We're going to have 0, okay, we're having 0 0 plus minus j, so it's going to be, not minus j, it is 0 into minus j is 0, this term is also going to be 0, so it is 0 plus 0, here it is going to have an output of 0, because 0 into minus j is 0, again here again 0, so 0 plus 0 is 0, then here we have minus 3 plus j, so let me write minus 3 plus j plus, okay, what about this term, minus 1 plus 3j, so minus 1 plus 3j into this term, right, into its weight, so it is minus 1 by root 2 minus j 1 by root 2, fine, okay, we should be a bit careful while calculating. And what about here, this term, okay, it is 10, we have 10 here, and we have 10 into 1 is 1, 10 into 1 is 10, and 10 into minus 1 is minus 10, so it is 10 minus 10 is going to be 0, this 10 minus 10 into 1 into minus 1, so it is 10, and 10 minus 10 is going to be 0 at this point, and here is going to be, right, okay, minus 3 minus j, so it is minus 3 minus j minus, okay, minus 1 minus 3j into 1 by root 2 minus j into 1 by root 2, right, okay. So what about this point? It's going to be 0, again 0 into something, so this point is again going to be 0, and output at this point is going to be like minus 3 plus j, so minus 3 plus j plus, okay, again minus, okay, minus 1 plus 3j into this, right, so minus 1 by root 2 minus j into 1 by root 2, okay, right, this is going to be an output, okay. So now you need to solve this output, okay. So as an easy method, you can use your calculator, okay. So let's solve, okay, let's solve it directly. so that let's see, it will be easy to make, and if you don't have calculator you can solve it directly also. So provided this is a structure and it's just a basic computation we are discussing, so 20 is fine, not an issue. Let me take a different sheet and solve the problem for you. So here we have what is minus 3 minus j plus minus 1 minus 3j into, so instead of 1 by root 2 it's nothing but 0.7107, so 1 by root 2 is nothing but 0.707. okay, I'll write as 0.707, so it will be easy to compute 0.707 minus j into 0.70, right, j into 0.707. so this is going to be minus 3 minus j, let me multiply with minus 1, so it's going to be minus 0.707 plus j into 0.707. Again we have 3j here, so 3 into 0.707, so 3 into 0.707 is, it will be around 2.12. so basically, right, so now we'll multiply with minus 3j, it's going to be minus 2.12 minus j into 2.12, then we have minus and minus plus, okay, but here it is j square, j into j is j square, which is equal to minus 1, so minus into minus will become plus, again is going to be minus, so minus j into 2.12. okay, solving this we can sorry, there is not going to be any j here because j into j is minus 1, okay, so we have to take off the j. So let's solve the j terms first, okay, we solve the j terms, so what we have is plus j 0.707 minus j into 2.12, so it's going to be like 1.414, right, so again you minus 1.414, again you have minus j here, so what you get is minus 2. Let's add it, okay, 2.12.707, we just subtract it, what you get is 1.414, okay, it should be around 1.414. so just substitute, so this is like solving this two, will get minus 1.414j, and here minus, already you have minus j, so it is 2.414j, okay, so minus 2. Minus 2.414j. So then we'll just add this term, the real part, minus 3.707, again we have minus 2.12, so this is going to be, if you add this, is going to be like minus 5.82, so minus 5.828, like in simple terms, write a real part image minus 5.828 minus j into 2.414. So this term, okay, this term is going to have a value of minus 5.82 minus j into 2.14. This term is going to be 0, and if you just solve this term, what you get is, okay, I'm not solving here, my aim here is just make you understand. So if you just substitute it, the answer is minus, okay, 0.172 plus j into 0.414. This is what you'll get answer. Again, if you're going to substitute this, the answer that I'm going to get is minus 0.172 plus j into 0.414. Again, if you go to last parameter, the answer that you get is minus 5.828 plus j into 2.414. Okay, so here let's write minus 5.828 minus j into 2.414. So please take down the answer and write. Is very important. So the output, okay, x of n is going to be 20 comma, okay, it's going to be same order, minus 5.82 plus j into, sorry, minus, okay, it's minus j 2.414 comma 0 comma minus 0.172 plus j into 0.414. Okay, so I think it's going to be minus. Okay, I'm sorry. Okay, you can just calculate it. So it is minus, so again 0, again 0.172 plus j into 0.414 comma 0 comma minus 5.828 plus j into 0.414. So please write the answer. Okay, take and write the answer. So that's it. Okay, so the more important part is okay, calculation. You can use your calculators, or this you can, okay, just understand how the flow is. So basically what you should know, understand is the input has to be bit reversed. Again, first we perform in stage 1. Okay, so as we have seen, we have here 2-point DFT, then we just combine this 2-point DFT to get, you know, the 4-point, then we just combine 2 4-point to get your 8-point. Okay, so this is your answer, and thank you for watching.